Have you ever been stuck wrestling with a super complex network design just to get a simple firewall or a load balancer plugged in? Well, today we're going to dive into a really powerful feature in Cisco ACI that completely changes the game. It's called Service Graph with Policy-Based Routing, or PBR. We're going to see how it makes adding network services a whole lot simpler, way smarter, and incredibly flexible.
All right, so here's our game plan. First, we're going to cover the basics of what service insertion even means in ACI. Then, we'll take a look at the old, kind of clunky way of doing things in routed mode, and then contrast that with the clean, new approach using PBR. We'll do the exact same thing for transparent mode, check out some really cool real-world examples, and then we'll tie it all together with the key things you need to remember.
So let's kick things off at square one. To really appreciate why PBR is such a big deal, we first have to get a handle on the actual problem it was designed to solve in the first place.
Okay, so at its heart, policy-based routing, or PBR, is basically a way for us to intelligently redirect traffic to our service devices, things like firewalls and load balancers, without making them the default gateway. You can almost think of it like a smart traffic cop. Instead of every car following the exact same rigid path, we can set up policies that say, hey, this specific type of traffic, you need to take a quick detour through this security checkpoint over here. This totally avoids a ton of complex routing headaches and gives us an incredible amount of flexibility.
To really appreciate just how elegant this new solution is, we have to understand the pain of the old way. So let's take a quick step back and see how Layer 3 service insertion used to be done in ACI before PBR really became the standard way to do things.
Okay, I want you to focus on the diagram up top. This shows the old way, what we call a VRF sandwich. It's kind of what it sounds like. To get traffic from the outside world through our firewall and then to our web servers, we actually had to create two totally separate routing tables, or VRFs. So traffic would come in on VRF1, get forced over to the firewall, and then the firewall would have to route it back into the ACI fabric, but on a different table, VRF2. I mean, it works, but you can see that's a whole lot of plumbing just to inspect some packets. And this whole sandwich approach brings a lot of headaches with it. You're juggling multiple VRFs, multiple external connections, the firewall is totally locked in as a mandatory hop in the path, and maybe the biggest problem, it's all or nothing. All of the traffic is forced through that firewall, even if it doesn't need to be inspected. And it's this lack of granular control that PBR is about to solve beautifully.
All right, now for the fun part. Let's see how we can completely clean up all that complexity. This is the new way, routed mode, but with policy-based routing.
And boom, this single image really shows the power. Just look at the bottom diagram. That entire complex 2VRF mesh we just talked about, it's gone. It's all collapsed down into just one single VRF. The firewall is still there, doing its job, but it's no longer a required gateway. Instead, the ACI fabric itself uses a policy to intelligently send only the traffic we care about to the firewall. The whole design is just cleaner, simpler, and way more efficient.
This table here really just drives the point home, doesn't it? We go from needing multiple VRFs down to just one, from a complex, rigid design to a super simplified and flexible one. And I think this is the most important part. We go from forcing all traffic through a service device to selectively redirecting only the traffic we want to inspect. This isn't just some small improvement, it's a fundamentally better way to operate.
Now you might be thinking, okay, that's great for Layer 3, but the power of PBR isn't just limited to routed services. It brings that same beautiful simplification to our transparent or Layer 2 services as well. Let's check that out.
And here we go again, right? Take a look at the top diagram. We see a very familiar pattern, but this time it's happening at Layer 2. To insert something like a transparent firewall, we had to build what's called a bridge domain sandwich. We're essentially stitching two separate Layer 2 networks together with the firewall sitting right in the middle, making it a mandatory bump in the wire for every single packet that goes through.
And now, let's look at the bottom diagram. Just like before, PBR comes in and cleans this whole mess up. We can completely get rid of that complicated bridge domain stitching. The fabric itself stays as one simple single Layer 2 domain, and we just use a PBR policy to steer the specific traffic that needs inspection over to that transparent firewall. It's the exact same principle of simplification, just applied at Layer 2 this time.
So the key thing to take away here is really simple. All of those awesome benefits of selective, policy-driven redirection that we just saw at Layer 3, well, they now apply to our Layer 2 services too. Doesn't matter if it's an inline IPS or a transparent firewall, we can get rid of that sandwich complexity and just let the ACI fabric intelligently handle all the traffic steering for us. Okay, that's enough of the theory. Let's see what this actually looks like in practice. How can we use these PBR policies to solve real-world problems with some serious granular control?
This is a perfect example of just how powerful PBR can be. Imagine we have two different groups of applications, or what ACI calls endpoint groups, EPGs for short. With PBR, we can easily create a policy that says any traffic coming from EPG A that's trying to get to the internet, well, that has to go through Firewall 1. And at the exact same time, we can have a totally separate policy that sends all the traffic from EPG B to a completely different device, Firewall 2. We're steering traffic based on where it comes from, which is just incredibly useful.
Okay, now let's get even more specific. What if we don't really care about who is sending the traffic, but we care a lot about what the traffic is? In this example, our policy gets super granular. It basically says, if the traffic is web traffic, HTTP, then redirect it over to the service node for a full inspection. But any other traffic, like maybe some database replication, that can completely bypass the service node and go straight to its destination. This is true application-aware networking.
So how does all this magic actually work? Well, it's not really magic. It's all defined in the ACI contract. Think of it like a set of rules that gets checked in order. So first, traffic flows from the client and hits steps 1 and 2. There's a rule there that's looking specifically for HTTP traffic. If it's a match, step 3 kicks in and the PBR policy sends that traffic over to the service node. Now, if the traffic is not HTTP, it doesn't match that first rule, so it just falls through to steps 4 and 5, where there's a second, more general rule that basically says permit everything else. And that allows all the non-web traffic to bypass the service node entirely. It's this simple, ordered logic that gives us such precise control.
All right, let's bring it all home. We've covered a lot of ground here, from the problems of old-school service insertion all the way to the really elegant solutions that PBR brings to the table. Let's quickly recap what we've learned, and then I'll give you a little peek at where you can take this knowledge next.
So, if you only remember a few things from our chat today, let it be these key benefits. Number 1, simplification. We're tearing down those crazy sandwich designs. 2, flexibility. You can deploy your services wherever you want. They're no longer tied to being the default gateway. And 3, granularity. You get surgical, precise control over exactly what traffic gets inspected. At the end of the day, all of this just means your network is easier to manage, easier to troubleshoot, and easier to scale.
And honestly, we've only just scratched the surface today. PBR opens the door to even more advanced setups. For example, you can do multi-node redirection. You might know it as service chaining, to send traffic through, say, a firewall first, then an IPS, then maybe an analytics engine. Or you could use something called ECMP hashing to load balance your traffic across a whole pool of firewalls, which lets you build these massively scalable and resilient security zones.
So I'll leave you with this question to think about for your own environment. Where are the spots in your network today where you have these rigid, complex service chains? What security or traffic engineering problems could you solve if you had this kind of precise, policy-driven control? As you can see, the possibilities here for making things simpler and more innovative are, well, they're pretty exciting.